This is a review for sections 11.1 through 11.3 for the test we have for college algebra. We have sequences and series, and we had a lot of formulas in this chapter. You should have this formula sheet handy. Just a quick review of all of our different definitions and formulas. And just so you know, on the test, you will be given a sheet that has all of these formulas. However, they are just going to be kind of in a mismatched order. They're not going to be like they are laid out in this chart. So for example, you might have the formula somewhere on a page that looks like this, and you need to be able to know that that is the formula for an infinite geometric sequence or series when you are finding a sum. Okay? So again, you'll have formulas just randomly placed on a sheet of paper. You will need to identify which ones are geometric, which ones are arithmetic. Are they helping you find a term of the sequence, or are they helping you find the sum of the whole series? So a couple things to notice. All of our arithmetic ones involve the letter D. All right? Our definition for an arithmetic sequence is that it has a common difference, and we find that by taking the second term minus the first term. And you'll notice that there's a D in all of our formulas dealing with setting up an arithmetic sequence. All right, we have two types. We have explicit and recursive. Explicit is the one that we use when we're trying to find just a single term somewhere in our sequence. Recursive is what we use if we want to build a whole sequence from a starting number. All right, so for an explicit formula for arithmetic, we have the first term plus n minus 1 of our common differences added to it. All right, we had a second option. We could back up one term. Instead of starting with the first term, we could start with the 0th term, and then we are adding n times d to that. Our recursive formula says we're going to be given our first number, and then we want to generate the sequence by continuing to add d to the previous number. Remember, this piece right here stands for the previous term. Okay? If we are summing a finite arithmetic sequence, this is the one where we paired the first and last terms. We added those two together, our first and our last. And we said all of the pairings, first and last, second and second to last, third and third to last, that type of thing, all of those pairings are going to add up to the same thing. And because we're pairing them up, we have n divided by 2, or half of those pieces. All right, and for an infinite arithmetic series, there is no way to find the sum. So we don't have a formula there. For the geometric ones, all of our formulas involve an R value, R standing for the common ratio. We find that by taking the second term divided by the first term. Our explicit formula is first term times R to the n minus 1 power. Our recursive formula, again, you'd have to be given the first term to start it out, and then we take the previous term and multiply it by R, our common ratio. And then remember, for the geometric series, we have two different formulas, one for a finite sum and one if we're looking at an infinite one. Okay, similar pieces, they both have an a sub 1 on top. They both have a 1 minus r in the denominator. The only difference is for the finite one, they also have this extra 1 minus r to the nth power. And in that formula, knowing where those parentheses need to be is really critical. All right. You also might want to put parentheses there. We do have to divide by the whole denominator. All right. So we're going to go through that review packet that you've had time to work on. Our first question, it says to write the first 4 terms of the sequence whose general term is given. So they're giving us this formula, a sub n is equal to just 3 times n. So if we want to find our first term, our n value here is 1. We're just going to take 3 times 1, which gives us a 3. If we want to take the second term, we're going to take 3 times our n value of 2, which gives us a 6. Our third term would be 3 times 3, or 9, and our fourth term would be 3 times 4, or 12. So the first 4 terms would be 3 6, 9, and 12. All right, question 2. Formula says take 3 times the quantity 2 times n minus 1. So again, first term, our n value is 1. So we have 3 times 2 times 1 minus 1, which would be 3 times 1, or just a 3. Our second term is 3 times the quantity 2 times 2 minus 1, which would be 4 minus 1, or 3. 3 times 3, which is 9. Our third term would be 3 times 2 times 3 minus 1. 6 minus 1 is 5. 3 times 5 would give us 15. And our fourth term, 3 times 2 times 4 minus 1. 8 minus 1 is 7. 7 times 3 would be 21. All right, our third question says we are taking 2/3 to the nth power. So our first term is just 2/3 to the first power, or 2/3. Our second term would be 2/3 to the second power, and if we square the 2, we get 4. Squaring the 3, we get 9. Our third term is 2/3 to the third power. So 2 cubed would be 8, and 3 cubed would be 27. We get 8/27. And then our fourth term would be 2/3 raised to the fourth power. 2 to the fourth is 16. 3 to the fourth would be 81. The next set of questions says write the first 4 terms of the sequence defined by the recursion formula. So they're giving us, instead of an explicit formula like we just had in the first 3 examples, now we're looking at recursive formulas. So they're basing it off the previous term. So this one says we're starting with a 5. Our first term is a 5. And all of the terms in our sequence can be found by taking 3 times the previous term. Remember, a sub n minus 1 stands for the previous term, and then subtracting 4 for that. All right, so we want the first 4 terms. They've already given us the first term is 5. Okay, to find the second term, we're going to take 3 times the previous term, which was a 5, and subtract 4, which gives us 15 minus 4, or 11. To find the third term, we take 3 times the previous answer and subtract 4. Well, our previous answer was an 11, so we'll dump an 11 in there. We have 33 minus 4, or 29. And then our fourth term is going to be 3 times that 29 minus 4, which should give us an 83. All right, question 5. It says our first term is negative 3. Our second term is found by taking negative 2 times the previous number. So our second term is going to be negative 2 times our previous number of negative 3, which gives us a 6. Our third term is negative 2 times our previous answer, 6, which gives us a negative 12. And our fourth term would be negative 2 times our previous answer of negative 12, which gives us a positive 24. All right, question 6 is to write the first 4 terms of the sequence whose general term is given. So again, they're giving us some kind of formula to use. It says a sub n is n plus 1 factorial, that's an exclamation point, n plus 1 factorial times, or divided by n to the third power. So our first term is going to be 1 plus 1 factorial divided by 1 to the third power. Well, 1 plus 1 is 2. 2 factorial means 2 times 1. And 1 cubed is 1, which gives us just a 2. Our second term says take 2 plus 1 factorial divided by 2 cubed. All right, well, 2 plus 1 is 3. 3 factorial is 3 times 2 times 1. And on the bottom, 2 cubed would be an 8. So we get 6/8, or 3/4 if we reduce it. All right, our third term would be 3 plus 1 factorial divided by 3 to the third power. 3 plus 1 is 4. 4 factorial is 4 times 3 times 2 times 1, which is 24, divided by 3 cubed, which is 27. That could be reduced to 8/9. And then our fourth term is 4 plus 1 factorial divided by 4 to the third power. 5 factorial would be 5 times 4 times 3 times 2 times 1. That is 120. And divide it by 4 cubed, which is 64. And again, that could be reduced down to 15/8. All right, question 7. It says to just evaluate the factorial expression. So we've got 8 factorial, which is 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And we are dividing by two different factorials. 6 factorial, so 6 times 5 times 4 times 3 times 2 times 1, times 2 factorial, or 2 times 1. And we can do a lot of simplifying here before we even grab a calculator, because we have 6, 5, 4, 3, 2, 1 on the top and the bottom. Those are going to cancel each other out. So we really just have 8 times 7, or 56, divided by 2 times 1, or 2, which gives us 28. All right, moving on to the next page. It says to find the indicated sum. Now, we've had some questions throughout this chapter where there's a summation notation, and the formula that they're giving us is arithmetic or geometric. In that case, I would like you to go ahead and use the formulas that we've been learning. If it is not arithmetic or geometric, then we just need to create the list of terms in our sequence and add them together. So in this first example here, question 8, I to the second power minus 10. It does not fit an arithmetic or a geometric formula. So we have to actually create the numbers in our sequence and then add them up. Notice we are starting with a 3 and we're stopping with a 5 for our I value. So we're really summing the third term, the fourth term, and the fifth term. All right, so if we put a 3 in there, 3 squared minus 10, 9 minus 10 would be negative 1. If we put a 4 in for I, 4 squared minus 10, or 16 minus 10 would be 6. And if we put a 5 in there, 5 squared minus 10 would be 25 minus 10, or 15. And it says to just add those numbers up. That's what our summation symbol here means. And negative 1 plus 6 would be 5, plus 15, we should get a total of 20. All right, question 9. Notice we are starting with I being 2 and stopping with it being 5. But the formula that they're giving us, 4i minus 5, that is an arithmetic sequence. Remember, if it looks like a linear equation, kind of like that y equals mx plus b, it is arithmetic. So let's go ahead and use our arithmetic formula for our sum. We have our first term, which is actually the value we get when we plug the first number in. Not necessarily a 1, but the first number. And in this case, we are dumping a 2 in first. So our first term, and I'm going to put it in quotes because it's really not plugging a 1 in, but it's the first term in my list. We're putting a 2 in, 4 times 2 minus 5. So my first number in my list would be a 3. How many terms am I adding up? Well, I'm going from I being 2 to I being 3 to 4 to 5. That's 4 values. All right, so we now have to find the last term, which in our case here, the last number that we would be dumping in is a 5. So let's find our last term. If we put a 5 in there, 4 times 5 minus 5 would be 15. So we have our first and our last term. And I am going to rewrite this here as a sub 2 because that is the first term in our sequence, is what we got when we plugged a 2 in there. And now we have to sum these 4 terms, a sub 2, a sub 3, a sub 4, and a sub 5. To do our summation, we are going to have n divided by 2, so 4 divided by 2, times first term plus last term. First term we found was a 3, last term was a 15. So 4 divided by 2 would be 2, 3 plus 15 is 18, 2 times 18 would be 36. Now, we can also check that because we could calculate a sub 2, a sub 3, a sub 4, a sub 5 and add them all up. We still should get 36 for an answer. All right, question 10. This one is not arithmetic or geometric again, so we are going to have to go ahead and find all of the terms. It says to start with a 5 and end with an 8. So we need term 5, 6, 7, and 8. But look at our formula. It's just a plain 4. That means every term is a 4. It doesn't matter what term we're looking for. They are all just plain 4s. So adding them up, 4 plus 4 plus 4 plus 4 would be 16. All right, question 11. This one is geometric. How I know that is we are taking a number to a power. That's like r to the n minus 1 or r to a power. So this is geometric. So I'm going to go ahead and use my geometric formulas. All right, it says we are starting with a 1 and stopping with a 4. So if we think about what our r value should be, we need a term 1, 2, 3, and 4. Sorry, our n value. We have terms 1, 2, 3, and 4. So n, we are summing 4 terms. Our r value is what is being raised to the power, which in this case is a 5. We're going to keep multiplying by 5s each time. And then our first term is what we get when we plug our first number in, which they've said is a 1. So 5 to the first power would just be a 5. All right, now we need our sum of those 4 terms. And because this is finite, we have the more complicated looking formula. We have first term times 1 minus our r value to the nth power, in this case of 4, divided by 1 minus r. All right. Using our calculators, we should get a sum of 780. And once again, we could check that. We could calculate the first term, the second term, the third term, the fourth term. We said a sub 1 was 5, a sub 2, 5 squared would be 25, a sub 3, 5 cubed is 125, a sub 4 would be 5 to the 4th, or 625. And again, if we added 5 plus 25 plus 125 plus 625, we should end up with 780 as well. All right, question 12. Says to find the common difference for the arithmetic sequence. Remember, our common difference is always to take the second term minus the first term. So if we take 718 minus 709, our common difference is just 9. Question 13. If we take the second term, negative 5, minus our first term, negative 1, we're really taking negative 5 plus 1. Our common difference would be negative 4. Question 14 says to find the first 5 terms of the arithmetic sequence. We are told our first term is 9 and our common difference is 3. That means we're just going to continue to add 3. And we want the first 5 terms. We're told the first term is 9. If we add 3 every single time, what do we get? So 9 plus 3 would be 12. 12 plus 3 would be 15. 15 plus 3 would be 18. 18 plus 3 would be 21. 15, same thing. They're asking us to find the first 5 terms of the arithmetic sequence, but this time it is given as a recursive formula. We have right here the statement that our nth term, any term in our sequence, is found by taking the previous one and subtracting 3. All right, so again, we need 5 terms. I think I'll write it out a different way for this one. First term is negative 20. Second term says to take the previous answer, negative 20, subtract 3 from it, which gives us negative 23. Then we're going to take the previous number. Previous number is negative 23. We're going to subtract 3. We get negative 26. Our fourth term, we're going to take the previous number, subtract 3, which gives us negative 29. And our fifth number, we're going to take the previous answer, previous term, subtract 3, which gives us negative 32. All right. Next set of questions says use the formula for the general term, the nth term of an arithmetic sequence to find the indicated term of the sequence with the given first term a sub 1 and a common difference of d. So it says to find a sub 17. We want the 17th term. That means we don't want to generate all 16 terms in front of it. We want to just use our explicit formula to find that 17th term. Our first term is 21. Our common difference is negative 6. So to find a sub 17, we're going to use our formula that says take the first term, I'll write it out here, take the first term and add n minus 1 of our common differences to it. All right, so our first term is 21. We're going to add 17 minus 1, or 16, of our common differences of negative 6. So 21 plus 16 times negative 6, we should end up with negative 75. All right. For question 17, we're looking for a sub 26. Our first term is 6. Our common difference is 3. We can do the same thing we just did, or I could find a generic formula. A sub n equals first term plus n minus 1 times our common difference. And if I do some distributing, we get 3n minus 3 plus our 6. So my a sub n value, in other words, any term in my sequence, can be found by taking 3 and adding 3n. And now that I have that formula, I can find a sub 26 simply by putting a 26 in for n. I should get 81 for an answer. All right, so either method, the one I used in example 16 or 17, either one would work. Our next set of questions is to write a formula for the general term or the nth term of the arithmetic sequence, and then use that formula to find the 20th term. All right, so what are we given? We're given the first 5 numbers in our sequence. So we know our first term is 1, and we can find our common difference by simply subtracting the second term minus the first term. So that means we are adding 4 to get to the next few terms. We do not want to continue this out to the 20th term. We want to use our nth term formula. A sub n is first term plus n minus 1 times d. Notice it says to write a formula for the general term. So they don't want us to jump to finding the 20th term right away. They want us to do what I just did in number 17, which was to come up with an equation first and then use that equation to find the 20th term. So we're going to plug in what we know. Our first term is 1, and our common difference is 4. If we do our distributing, we've got 4n minus 4 plus the 1. So our nth term is going to be 4n minus 3, or negative 3 plus 4n. Either way is fine. That is going to get you part of the points for this question. It asks us to come up with a formula for the nth term, and we have. Now it says to use that formula to find the 20th term. So a sub 20 would be negative 3 plus 4 times 20. Well, 4 times 20 is 80. 80 minus 3 would be 77. So our 20th term is 77. Question 19. Write out the first 3 terms and the last term of the arithmetic sequence. So we are going from 1 to 13. They're not asking us to create the whole list. They just are saying to write out the first couple terms and the very last one. So what we get when we put in a 1, a 2, a 3, and then we're going to skip to plugging in a 13. All right, so if we put a 1 in here, we've got 4 times 1 plus 1, which would be 4 plus 1, or 5. Our next one is 4 times 2 plus 1. 8 plus 1 would be 9. Our next one is 4 times 3 plus 1. 12 plus 1 would be 13. And then again, we're going to skip over a couple, and we're going to put a 13 in for I. So 4 times 13 plus 1, which is 53. Question 20. says use the formula for the sum of the first n terms of the arithmetic sequence to find the indicated sum. The things that we need to know, it is arithmetic, so we have to know what our n value is, we need to know what our first term is, and we need to know what our nth term is. All right, so how many numbers are we summing? We're going from 1 to 49. That would be 49 numbers. Our first term is what we get when we put a 1 in there. So 4 times 1 plus 6. Our first term is a 10. And then a sub n, which in this case is going to be a sub 49, since we're finding 49 terms. So we're going to put a 49 in there. 4 times 49 plus 6, which gives us 202. All right, now we can plug it into our summation formula. We are summing 49 numbers. This is an arithmetic one, so our formula is n divided by 2, so 49 divided by 2, times the sum of our first plus last. Our first term was 10, our last term was 202. Using our calculators, we should get 5,194 for an answer. Question 21, we are going from 1 to 60. So our n value is 60 numbers. Our first term is what we get when we plug that in. Putting a 1 in, we get -4. Our last term in this case would be our 60th number, and that's what we get when we dump a 60 in for I. So -4 times 60 would be -240. All right, so using that same formula we just had, we are summing 60 numbers. So we're going to have n divided by 2, 60 divided by 2, times the sum of our first plus our last. So 60 divided by 2 would be 30. -4 plus -240 is -244. When we do that multiplication, we should get a sum of those 60 numbers being -7,320. All right, question 22 says to find the sum of the first 50 terms of the arithmetic sequence. Now, a couple things to notice here. It is arithmetic, so we are looking at the same formula we just have been using, but they do not give us the last term. We know our n value is 50 because they said to add the first 50 numbers. We know our first term is -14, but we are going to have to find our 50th term. All right, so our last term, we start with our first one, -14. We're going to add n minus 1 of our common differences. N is 50, so 50 minus 1 or 49. Our common difference, we are taking our second term minus our previous term of -14, which gives us a -7 for a common difference. All right, so I have -14 plus 49 times -7. Our 50th term should be -357. And now we can plug that into our formula. So the sum of our 50 numbers, we're going to pair them up. So 50 divided by 2 times the first plus the last. And we should get a sum of -9,275. Question 23, it says a theater has 30 rows with 25 seats in the first row, 29 seats in the second row, 33 in the third row, and so forth. How many seats are in the theater? So they want us to total all the seats in the theater. So we are looking at a summation. We are told that there are 30 rows that we're adding up, and we are given the first few terms. We're told the first row has 25, the next row has 29, the next row has 33, etc. So we can look at this and say our common difference is going to be 4. We're adding 4 more seats to each row. In order to sum this arithmetic sequence, we are going to need to know our first and last terms. We know our first term is 25, but we are going to have to figure out how many seats are in that 30th row. So we're going to find a sub 30. We take our first term plus n minus 1, so 30 minus 1, times that common difference of 4. So 25 plus 29 times 4, our 30th row should have 141 seats in it. All right, now we can plug it into our summation formula. We have 30 rows, we're pairing them up. Each pair has a sum of first term plus last term. So we have 15 times 166, we get 2,490. Question 24, it says, as part of her retirement savings plan, Patricia deposits $150 in a bank account during her first year in the workforce. During each subsequent year, she deposits $45 more than the previous year. Find how much she has deposited during her 20th year in the workforce. And then find the total amount deposited in all 20 years. So a couple different things we're being asked for. We do know that our first amount is 150. We know that our common difference each year, she's adding an extra $45. So our first year she put in 150, the next year she put in 195, etc. In order to find the 20th term, we need to know our first term plus n minus 1, so 20 minus 1, times our common difference of 45. So in her 20th year, she is putting in $1,005 into her retirement savings plan. Now, to figure out how much she will have at the end of all those 20 years, we need to sum all of her 20 payments. So 20 divided by 2 times first plus last. And the last term, the 20th term, we just found to be $1,005. Totals up to be $11,550 that she has put into her savings account. Question 25, it says if the given sequence is a geometric sequence, find the common ratio. To do that, remember, we just take second term divided by first term. So -9 divided by 3, our common ratio would be -3. In question 26, it's a little more complicated because the terms are fractions, but we can still do this. We take 3/16 and we divide it by 3/4. But remember, dividing by a fraction is the same as multiplying by a reciprocal. So we have 3/16 times the reciprocal of 4/3. The 3's will cancel each other out. We can reduce the 4 and 16 to 1 and 4. So my common ratio would be 1/4. All right, question 27. It says write the first 5 terms of the geometric sequence. We are starting with -7, and it says our R value is -4. That means we're going to continue to multiply by -4. So my first number is -7. My second number is -7 times -4, or 28. My third number is going to be -7 times -4 twice, right? N minus 1 is my exponent, and 3 minus 1 would be 2. That gives me -112. My fourth term is going to take -7 times -4 to the third power. We should get 448 for that. And my fifth term would be -7 times that R value to the n minus 1, or fourth power, -1,792. Question 28. My first term is 5. My second term is 5 times R to the first power. N minus 1 would be 1. We get 5/3. All right. Third term is 5 times 1/3. Again, n minus 1, 3 minus 1 would be 2. Squaring that gives me 1/9. 5 times 1/9 is 5/9. A sub 4. I have 5, my first term, times R to the 4 minus 1, or third power. Cubing 1/3 gives me 1/27. Timesing by 5 gives me 5/27. And our fifth term 5 times 1/3 to the 5 minus 1 power, or 4th power. 1/3 to the 4th power is 1 over 81. We get 5 over 81. All right, last page. Question 29 says, find the indicated sum. Use the formula for the sum of the first n terms of the geometric sequence. So the first thing we have to do is figure out, is this finite or infinite? Because we are stopping after the 5th number there, it is a finite one, so we need our sum for a finite geometric series. So first term times 1 minus our r value to the nth power over 1 minus r. All right, so what do we know? Our first term is what we get when we put a 1 in there. So 4 times -3 to the 1st power would be -12. Our r value is what we keep multiplying by each time, which is an extra -3. So our sum, going from 1 here to 5 here, we are summing 5 numbers. Our first term is -12. We have 1 minus the r value, and you are going to need parentheses around that, to the nth power, in this case of 5. Close off that top set of parentheses. On the bottom, we have 1 minus our r value. And using calculators, we should get -732. Question 30 says, use the formula for the sum of the first n terms of the geometric sequence to solve this. It says to find the sum of the first 14 terms. It is geometric. Our first term is 5. Our r value, what is it that we're multiplying by each time? We take our second term divided by our first term. So we are multiplying by a -3 to get each term after that. It says to find the sum of the first 14, so that is our n value, and that makes it finite even though we have the ... at the end. We are stopping after 14 terms. So summing 14 numbers, we have our first term of 5 times 1 minus our r value to the 14th power over 1 minus r. Our sum should be -5,978,710. Question 31 says a job that pays a salary of $25,000 the first year. During the next 10 years, the salary increases by 3% each year. That right there tells me it is geometric. What is the salary for the 11th year? And what is the total salary over all 11 years? So we know our first year was 25,000. To find the 11th term, we need our first term times r. And because we are going up by 3%, our r value is 1.03. That means we keep the initial 100% of what we had the previous year, plus we get an extra 3%. So we have 25,000 times 1.03, and we're doing this for 10 years. All right. We always have an n-1 exponent. N was 11, so we have 10 for our exponent. The 11th term then should be 33597.91, $33,597.91. All right, now it says to find the sum of those 11 terms. We are starting with 25,000. We have 1 minus r to the nth power, which is 11, over 1 minus r. Using calculators, our sum should be $320,194.89. Question 32, find the sum of the infinite geometric series if it exists. So 2 things here. It's infinite, and we have to check if it exists. Remember, infinite sequences that are geometric, we can only find their sum if the sequence diverges. if the sequence converges, meaning the numbers keep getting smaller and smaller. So looking at our sequence here, we have 24, then 12, then 6, then 3. Since our numbers are getting smaller and smaller and smaller, it does converge. We can find the sum. All right, this is our smaller formula. S equals a sub 1 over 1 minus r. So our first term we are given is 24. We need 1 minus our r value. R, remember, is found by taking the second term divided by the first term. So 12 divided by 24 would be 1/2. So we plug that in. 1 minus 1/2 is 1/2. We have 24. We're dividing by 1/2, which is the same as multiplying by 2, which gives us 48 for a sum. Question 33. It says a football player signs a contract with a salary of $810,000 per year and an annual increase of 4.5% beginning in the second year. What will this athlete's salary be to the nearest dollar in the 7th year? So we're not summing anything, we're just trying to find the 7th term. We know our first term is 810,000. It is geometric because we are increasing by a percent, a fixed percent. Our R value, remember, is always 1 plus the percent, so 1.045, and we are looking for the 7th term. So a sub 7 is our first term times our R value to the n minus 1 power. 7 minus 1, we'd have a 6 for an exponent. So our salary during the 7th year $1,054,830.70. All right, our last question, it says find the nth term. So a formula for the nth term. If D is -3, that means it is arithmetic. All right, since they're giving us a common difference. We are told the 77th term is 477. We can use that to help us figure out what our first term is. Remember, our formula for arithmetic is first term plus n minus 1 times our common difference. So let's plug in what we know. We know the common difference is -3. And we know that 477 is not our first term. We don't know that. But it is our 77th term. So we can put a 77 in here for n, and what we get is an answer of 477. All right, doing our arithmetic here, we have 76 times -3, which is -228. If we add the 228 to the other side, we get 705 is our first term. And now we can write our formula. So a sub n equals the first term plus n minus 1 times our common difference of -3. Distributing, we've got -3n plus 3. And combining like terms, we end up with an nth term of 708 minus 3n. All right, good luck on your test tomorrow.